figure out statements and reasons that go with that information. So in this example, we're just given this diagram, okay? And we're given angle 1 and angle 2. So you start have to ask yourself, what do I know about angle 1 and angle 2?
They both have the same. They both have the same.
You're right. But before we get why can we say that though? Why can we say that? What type of angles are they? No. You're on their track. What type of angles are 1 and 2? Starts with a V. Vertical. They're vertical angles. So we can state that. We know angle 1 and angle 2 are vertical angles. Again, I like to abbreviate. Okay? Our reason we can say that, we think we have a vocab word, our reason is going to be, think about what we did yesterday. That vocab word, yeah, definition of vertical angle. So whenever you have a vocab word in a statement or given information, your reason is going to be definition of that vocab word. We knew by the definition of knowing what the definition of vertical angles were, they're two angles formed by intersecting lines that are back to back. We can make that statement. Okay? Well, what do we know about vertical angles? Yeah, they're equal, they're congruent, they're the same. So knowing that these are vertical angles, we can then say that they're congruent using that vertical angle theorem. Okay? Theorems are different than definitions. Okay? The theorem tells us that vertical angles are congruent. The definition tells us in the diagram that we have vertical angles. So we would say vertical angle theorem. That's our reason. Questions over that? Take a look at another one. We are given that M is, what does this symbol mean? Perpendicular. M is perpendicular to P. So start thinking, well, what do I know about perpendicular lines? We're given lines. We know they're perpendicular. What do we know about them? They're lines that intersect and make a right angle. So can't we say that this angle right here, angle 1, is a right angle? And it's written in symbol form. It's written out in symbol, but we technically have a vocab word. Because if it was written out in sentence form, it would say M is perpendicular to P. It would have that vocab word there. So what do you think our reason is going to be? Definition of perpendicular lines. And I'm going to be perpendicular lines. Because we, by definition, perpendicular lines are lines that intersect and form right angles. So by using that definition, we know this angle is a right angle. Well, we can make another statement. If we know angle 1 is a right angle, what do we know about angle 1? What's it equal to? No? M is a line, not an angle. If we know angle 1 is a right angle, what do we know about the measure of angle 1? It's 90 degrees. So we can state that. We can say the measure of angle 1 is equal to 90 degrees. If we look at the previous statement, it says right angle. Isn't that a vocab word? So what do you think our reason is going to be? Definition of right angle. Definition of that vocab word. Again, that's how I abbreviate right angle. From the given information, we knew those lines were parallel. Using that info, we knew that angle 1 was a right angle. Using that information, information we knew it equals 90 degrees. It all kind of branches off one another. Okay. Questions over that? Okay. It says angle 1 and angle 2 are supplementary. What can we conclude from that? What statement can we make? Yeah, they add to 180, so we can write that. We can say the measure of angle 1 plus the measure of angle 2 equal 180 degrees. What do you think our reason for that's going to be? We have just a sentence with a vocab word. What's our reason? Definition of supplementary. What? Supplementary angles. Because we know that by definition, supplementary angles add to 180, we can make that statement. And that's how I abbreviate supplementary angles. Again, I love to abbreviate. Right, if we take a look at F, okay? While we're given this diagram, I'm going to help you with the first statement, and then we'll be able to get the second statement. But I notice here, what is the measure of the whole angle? The whole angle equals 90, right? Okay? And I notice this whole angle is made up of this little angle, ABD, and this other little angle, CBD. So what can we conclude about the sum of those two angles? What is the sum of those two angles going to equal? They add, we take this angle, add it to that angle, it's going to equal the whole big angle, right? So we can say that the measure of angle ABD plus the measure of angle CBD equals the measure of angle ABC. And our reason, oh, sorry, change that. We'll deal with that kind of later. But what did we say the whole angle was? That's my fault. What did we say the whole angle was? 90. So it's going to equal 90, right? And whenever we're in geometry, we're doing proofs. If you add two little angles together, and it equals the whole big angle, your reason every time is angle, addition, postulate. Because we added two angles together and it equaled the whole angle. We added the parts and it equaled the whole thing. Your reason is angle, addition, postulate. Remember we talked about that at the very beginning of the year. We add two angles and it equals the whole angle. Angle, addition, postulate. Okay? Now that we say this angle plus that angle equals 90, well, what do we call angles that add to 90 degrees? We can say that those two angles are what? Supplementary angles are add to 180. What are angles that add to 90? Complementary. So we can say that angle ABD plus angle CBD are complementary. Okay. And our reason is we have a vocab word. Our reason is definition of a what? What's our vocab word? Complementary. So our reason is getting definition of complementary angles. There's a pattern here. Vocab word. Reason is definition of a vocab word. Every time. By definition, complementary angles add to 90 degrees. Yes.
So it matters in what order you give it in?
Yes, because you can't say that they're complementary before you say they add to. We don't know. We had to state that they added to 90 in order for them to be complementary. Okay? If we're told that they're complementary, like if we were given, if it said these angles are complementary, then you could reverse it. But we weren't told. We just used the diagram. From the diagram, we got that they added 90. So because they add to 90, then we can say they're complementary. So sometimes order doesn't necessarily matter in proofs. Sometimes it does. You have to go a certain way, and you'll see examples of that. Because sometimes one thing has to be stated before you can state another thing. Okay, that's a good question. Other questions? Okay, so that part was just to kind of get the pattern of figuring out statements and reasons based off given information. Okay, so we're going to start diving into our first official geometry proofs, and these specific proofs, you're not going to be tested on these. These aren't these type of proofs are not going to be asked on your OC. Start diving into that stuff tomorrow. These are just kind of basic introductory, what I call baby proofs, to help you just get that pattern down for when we start to do real proofs that we're going to need to know for like the OST and throughout this unit. So when filling out a proof, again, we're filling out a 2-column proof. We have our statements in one column, our reasons in the other. Okay, we're given that B is the midpoint of AC. And we're trying to prove that AB plus CD equals BD. So think back to what we talked about yesterday. What did we say was our first statement every single time in any proof? You might need to flip back to your notes. The answer's not in your phone or on Snapchat or in the game that you're currently looking at. It's in your notes. You might need to flip back to that. What does it say? What do we write? First statement every single the given information. Very good. We always write our given information first. I'm going to abbreviate midpoint, mid-PT. And it is given. What is our last statement every single time? What you're trying to prove. Very good. We're trying to prove that AB plus CD equals BD. So then we just have to fill in the rest. Okay? Again, every single proof you do, what you're given goes first and your reason is given every single time. Your very last statement is what you're trying to prove every single time. We just don't know what the last reason is, so we leave that blank. But we know the first reason is given, because it's your given information. Okay? So I'm going to look at what I'm given. And I'm given that B is the midpoint of AC. So here's B. Okay? It's the midpoint of this segment. What can we conclude? What? Yeah, AB, I'm going to mark in my diagram, and CB are the same. They're congruent. So I can state that. I can say AB is congruent to CB. Why? What's our reason? Look at what we were given. Were we given a vocab word? We weren't given a vocab word? What's our vocab word we were given? Midpoint. What's our reason going to be? Definition of midpoint. Whenever we're given a vocab word, it's definition of that vocab word. This is, and a lot of times you'll see this with proofs. You'll have a proof partially filled out for you, and you just have to fill in the missing pieces. So they filled in this reason for us. This is definition of congruence, and this sometimes pops up in proofs. The reason why we do this, or why that's there, is because if you notice here, we have a congruent symbol. But later in our proof, we have an equal symbol. So we have to say consistent, okay? So what we have to do when that happens is take our congruent symbol and convert it to an equals. So whenever you see definition of congruence, that's just what you're doing. You're taking what you said is congruent and just stating that it's equal. So you're just stating that AB is equal to C. You have to put congruent first, technically they're congruent. I mean, it's more along the lines of when you're filling these on the OST, you're not writing things in. They give you boxes, and you drag and drop the boxes into the right spot. So it's based off what they give you, and more than likely they're giving you this. Okay? So that's the big thing with these is you kind of have to take what they gave you and figure out what goes where correctly. So we might fill something out a certain way, and they have a totally different idea of how to fill it out on the OST. So part of this is just getting good at just finding the pattern, figuring out what makes the most sense. Okay. So now that we converted, we went from congruent to equals, and whenever we convert to congruent to equals or vice versa, it's definition of congruence. This next statement and reason is saying segment addition postulate. That's like angle addition postulate, where we're adding two smaller angles or two smaller segments, and it's going to equal a big segment. So you just have to look in your diagram. It's saying BC plus CD. And if you combine BC and CD together, what's the big segment that they form? What is it for? BD. So BD is going to go in this blank. Using this segment addition postulate. This guy plus this guy equals the whole thing. Okay? If you notice from step 4 to step 5, they're almost identical. BD, we're adding CD, but these two are different. Okay? When that happens, okay, whenever you have two lines that are almost identical, but one thing is different, okay, your reason every single time, substitution. Here's why. Okay, we set up here that AB was the same as BC or CD. They're the same thing, just different order. Okay, so in step 3, we said that these two things were the same. Okay, so what we did was we took AB and replaced it where BC was. We're allowed to do that using substitution. Because we have two things that are the same, you can take one of them and substitute it in or replace the other. So whenever that happens, whenever you have two lines that are almost identical, but one thing changed, it's substitution. Every time. So just noticing that pattern. You might look at a proof and not know why they did that. But, oh, one thing changed from step 3 to step 4. I know my reason is substitution. I replaced something. Okay. Questions over that? If we take a look at example 6, it says complete the following 2-column proofs. We're given that angle 1 and angle 2 are straight angles, and we're going to try to prove that angle 1 is congruent to angle 2. So what's going to be our first statement? Every time. So give it. Every time. Angle 1 and angle 2 are straight. I've put it in their angles. And our reason every single time is just given. Okay. What's our last statement every time? What you're trying to prove. And we're trying to prove that angle 1 is congruent to angle 2. We just don't know the reason for that yet. Two, they filled out this statement for us. They said angle 1 is equal to 180 degrees and angle 2 is equal to 180 degrees. Why can we say that? Go to your given information. Do we have a vocab word? Yeah, our vocab word's straight angle. What do you think your reason is going to be? Definition of a straight angle. Whenever you're given a vocab word in your proof, you're going to use that as a reason. And by definition, what do straight angles equal? 180. That's why we can write that. They both are going to equal 180 because they're straight angles. That's their definition. Okay. 3 is stating the transitive property of equality. Okay. We talked about that one yesterday. Transitive property is where one thing equals another. So A equals B. B equals C. So then what do we know about an A and C? They also have to be what? the same. They also have to equal each other. So if 1 is equal to 180 and 2 is equal to 180, then what do we know about angle 1 and angle 2? They're the same. They're also going to equal each other. Using that transitive property. They both equal 180 degrees, so they both must equal each other. Just like A and C are both equal to B, so A and C must equal each other. Okay. And then if you notice here, we went from equals to congruence. When we go from equal to congruent, what's our reason? Just like the last one where we converted from equal to congruent. No? Look back at the proof. We went from equal to congruent. Definition of congruence. Whenever you convert from equal to congruent, definition of congruence, or vice versa. Okay? And if something is equal, two things are equal, they're also going to be congruent. Sometimes that pops up. It doesn't pop up a ton. But sometimes it does pop up. You gotta be aware. Whenever you go from equal to congruence, it's definition of congruence. Okay? Questions over that? We look at our last example. It says complete the following 2-column proof. Right? They only gave us 2 things. We have to fill in the rest. What is going to go first? What's our first statement? Huh? Good. And we use given. What's going to be our last statement every single time? We're doing the same thing. No. That's always our first. You can't write it twice. What you're trying to prove. Good. Angle ROT and angle NOT are complementary. Okay? Every time. I found that in you because when we take the test over proofs, I don't know how many students just leave things blank. Like you can at least get like 3 points by filling that part in. And usually that might get you moving on other ones. Right? So at least get that. Well, let's take a look at what we were given. We're given that angle R is a right angle. What can we conclude from that? What? Yeah, very good. Angle RON, angle RON, is 90 degrees. What's our reason for stating that? Definition of a right angle. We have a vocab word. Right angle. That's going to be our reason. Definition of a right angle. Okay. Angle addition postulate. That's where, again, like segment addition, we add 2 little things together to equal the big thing. So looking at this diagram, what's one of my little angles? ROT. ROT, if we add ROT together, so the measure of angle ROT, and if you forget the M, I'm not super picky about that, but technically the measure is supposed to be there. If you forget it, I'm not picky. Okay? What's the other little angle? TON. And I'm going to just make it the same here so you don't get confused. But if you wrote it TON, that's totally fine. Plus NOT is equal to, how would we name the big angle? What's the name of the big angle that they make up? RON. Angle RON. So whenever you see angle addition as a reason, your statement's going to be 2 little angles equaling a big angle. Okay? Or vice versa. If you just see 2 angles adding together to equal another angle, your reason's angle addition. Adding angles, angle addition postulate. Okay? If you notice from 3 to 4, aren't they almost exactly the same? But one thing changed. That now became 90. When that happens, what's our reason? Substitution. When one thing changes, your reason's always going to be substitution. The reason why it's substitution is we said that RON, angle RON, was 90 degrees. Angle RON's written right there. So we can take the 90 degrees and plug it in where angle rod is using that substitution. We replaced it. And then our last statement, because these two angles add to 90, we can then say they're complementary. What's our reason when we have a vocab word? Definition. Definition of complementary angles. Question. Proofs are just one of those things you have to do a lot of until you get that pattern down. Okay? Once you figure out those little patterns, those tricks of like definition of a vocab word, we'll learn some more tricks that will make our things even easier. Okay? They aren't that bad. Specifically, you don't have to fill out an entire thing on your own. You're given a word bank. So that's not that bad. Okay? Some of them I'm going to give you aren't going to require word banks, but a lot of the time you will have a word bank. Okay? Questions over that? So now what we're going to do is we're going to do some practice on whiteboard. So come on up, grab marker, whiteboard. We're just going to get some practice with kind of what we did at the beginning of this lesson, which is making reasons, figuring out what the correct reasons. Make sure you grab a whiteboard to you.